Welcome to Pasteboards, Services, and Interoperability on Mac. My name is James Dempsey. I'm an engineer on the Cocoa Frameworks team. And application interoperability on Mac OS X, two of the heavy hitters of application interoperability are Pasteboards and Services. So that's where we're going to be focusing our attention this afternoon. So Pasteboards and Services. Pasteboards really provide the foundation for transferring data between applications on Mac OS X. And then services build upon this foundation to allow an application to provide functionality that can be taken advantage of by any of the other applications on the system. Now, Pasteboards and Services aren't new. They've been around since 10.0 and earlier. And some of you remember. But another thing they have in common is that both Pasteboards and Services have had significant enhancements made in Snow Leopard. And that's what we're going to be talking about today. What's new with NS Pasteboard and Services in Snow Leopard? We'll first start out by going through the new NS Pasteboard APIs and how to use them. And then my colleague Peter Ammon will talk about how to provide and consume services in Snow Leopard. All right. Now, this is marked as an expert talk. We're expecting that you have some familiarity with those topics, but even if you don't, I think that through the context of the presentation, you should be able to pick up a lot if you just stay seated. And with that, let's jump in and start talking about NS Pasteboard item. So the Pasteboard really is the foundation for a lot of just fundamental user experience features on the Mac. So fundamental that we forget we're even using the feature anymore. Things like copy and paste and drag and drop. And of course, system services also rely on the Pasteboard. And really the purpose of NS Pasteboard is to allow for a very simple way, pretty straightforward way of sharing data between applications or within an application. Now, before we jump into the new Snow Leopard stuff, let's just do a very brief review of NS Pasteboard and how it has behaved since 10.0 and since, as far as we can tell, the beginning of time. So NS Pasteboard is kind of a cross-process dictionary-like structure. I kind of whimsically like to think of it as a magical dictionary that you get hold of it in one process, you instantiate it by name, and then you can set data for various types and add different data representations. So it's dictionary-like because the data is keyed by its type. And then in another process, you can ask for that same Pasteboard name, you get an NS Pasteboard instance, and then the data representations put on over here are available in another process, and you retrieve them again by type, by getting the data for particular types. Now, one way that it's not dictionary-like is that the order of those types, those data representations, has some meaning. In our example up here, we might have some rich text, some formatted text on the Pasteboard, and we're using the RTF format so that the richest representation of the data we're putting on the Pasteboard is always first. And then we might provide additional types. In this case, we're also providing some plain string data for an app like maybe Terminal that doesn't deal in rich text. So the first type is always the richest, and then the following types are either less rich or perhaps a translation of the original type. So that's kind of the NS Pasteboard in a nutshell, as we've known and loved it for many years now. So what have we done in Snow Leopard? Well, probably the largest thing that we've done is we've added support for multiple Pasteboard items. So whereas before, in my whimsical mind, it was a magical dictionary, we now have a magical array of dictionaries. So each of those items is conceptually very similar to what we have thought of for years as the Pasteboard. So multiple items, each item can contain multiple data representations, and again, the order is still important. The second thing we've done is, even though we've added new functionality to the Pasteboard, we've also been looking at ways to make it easier to do common Pasteboard operations. And so we've shifted the focus from always dealing in the nitty-gritty of each individual type to be able to work more at the class level and perhaps read and write things like NS colors and NS URLs directly on the pasteboard. And then finally, we're taking the opportunity of these other changes to also move away from pboard types and move to uniform type identifiers, which is a very rich typing system in Mac OS X. And actually, that will change those pboard types to UTIs on the pasteboard. So that's kind of a summary of the high-level changes we've made to the pasteboard in Snow Leopard. So but there's a lot of stuff in NS Pasteboard that we really like, things we wanted to preserve. So briefly to mention those, although we can work at this class level, we still want to preserve this ability to get in there to the nitty-gritty and get and set every piece of data on every item. NS Pasteboard has always had these great convenience methods where instead of just setting and getting data for a particular type, you could get and set strings and property lists. And the pasteboard would automatically serialize and deserialize for you. We've wanted to preserve those as well. And finally, the ability to provide data lazily, to promise to provide data at a later time and not necessarily do every expensive translation of types right up front. So those things to preserve will be common threads as we look at the new API. Okay, that all said, let's look at the new way of doing things in NS Pasteboard. Let's look at writing. So in our example here, we have not one, but 3 NS URLs. And what we'd like to do is have one item show up on the pasteboard for every NS URL. In Snow Leopard, we do something like this. We get hold of a pasteboard. Of course, it has what was previously on the pasteboard, so we clear the contents from what was previously there. And then we take that array of URLs and we simply tell the pasteboard to write these objects. And when we do that, the pasteboard will end up with one item per object that we handed it, and that item will have the appropriate types and data on it. Now, how does the pasteboard know what types of data are appropriate for a particular object? Well, NSURL implements a brand new protocol in Snow Leopard called NS Pasteboard Writing. And this protocol is implemented by NSURL as well as many common Cocoa classes. And we'll see in a little bit, it's a public protocol, so your objects can play along as well. So what does this operation look like in code? Something like this. So we have an array of URLs, and we get hold of a pasteboard. That hasn't changed at all in Snow Leopard. We clear the contents, and then we write the objects. We hand in that array of objects that implement NS Pasteboard Writing. And I don't know if we could have shortened it any more than that. Now, I mentioned other Cocoa classes implement this as well. So we can write URLs to the pasteboard, but we can all do the same with attributed strings for rich text data. Here we're just putting one item on, so we're throwing it into an array before we write the objects. NS image, NS color, NS string, and NS sound. So for all of the common Cocoa classes that you're typically putting on the pasteboard, reading off the pasteboard, writing is very straightforward. Now, how do your objects play along? Well, that's the NS Pasteboard Writing protocol. 3 methods to implement. Writable types for pasteboard. In that method, you return an array of UTIs of the types your object is willing to provide to the pasteboard. And again, the order of that array is important. The richest type should be first. Pasteboard property list for type is where you get asked for a type and you return the appropriate information that should be on the pasteboard. But you'll notice it's property list for type, not data for type. What's up with that? Well, if you give us back an NS data, if you return an NS data, that's certainly a property list type of object. We're going to use that data as is. However, if you return an NS string or any other property list object, it's as if you had called set data for type or set property list for type in the old API, and will automatically do the appropriate serialization to an NS data. And those are the only 2 methods that you have to implement, the only 2 that are required. You can also specify some writing options for each type, And in Snow Leopard, there's only one writing option, and it has to do with promising to provide a type. So by default, that array of types that you hand back, we'll write the first type immediately, and we'll just promise to write the additional types. If you want to change that default behavior, implement writing options for type, pasteboard, and return the NS pasteboard writing promised option, which means this type, the pasteboard shouldn't grab it right away, it should promise to provide it later, or no option at all, just 0. Note that an object that is promising types and written to the pasteboard is retained by the pasteboard because the pasteboard needs to fulfill that promise later, potentially. So if you're passing in a mutable object, you may want to copy it before writing it to the pasteboard. And that sums up writing. Let's talk about reading. So let's say we get hold of this pasteboard that we wrote to earlier, and we want to get some NS URLs off of it. Well, we ask the pasteboard, do you have any URLs? It'll run through each item. If it can construct a URL out of the types on that item, it'll make one for you. So in this case, the pasteboard will give us back an array of 3 NS URLs. So what does that look like? Oh, and of course, we had NS pasteboard writing. How does the pasteboard know how to do this? NS pasteboard reading, of course, which is implemented by the same Cocoa classes that implement the writing protocol. So in code, how does this work? Get hold of a pasteboard. We create an array of classes that we're looking for. Notice it can be more than one. And then we read objects for classes. There are some options we'll talk about in just a bit. And so it's in a fairly straightforward way, you can read multiple items at once. And in fact, even if there are mixed types on the pasteboard, you can read URLs, strings, images, attributed strings, all in one method call if you just hand in a long enough list of classes as the array. So that's writing, and that's reading. There's one other very common pasteboard operation, which is validating the contents of the pasteboard. So you may have a view, and a drag comes in, and you need to know, is there anything interesting on the pasteboard that my view is interested in? Therefore, I should validate and accept this drop. Or is there anything interesting on the pasteboard, and therefore I should enable my paste menu item? So we also wanted to make validating straightforward and easy. So there's one little change. Instead of reading the objects, we just ask if we can read object for classes. Again, get the pasteboard. First 2 lines are exactly the same. Specify some classes, and then ask if we can read. And again, with these 3 lines of code, you can potentially look for everything that your application is interested in without necessarily iterating through all the pasteboard items to check and that sort of thing. Now, we've had options arguments for the last 2 methods. It's the same set of options we can pass in for reading or validating whether we can read. Let's talk about those now. It's an options dictionary, and they both deal with reading NS URLs from the pasteboard. Now, it's very common. Applications very often may not be interested in web URLs. They may only want local file URLs. So in this options dictionary, you can say, I'm looking for file URLs only. Have an NS number Boolean, say yes. And in this example here, using this options dictionary to read URLs, out of those 5 items with URL data, we end up with only the 3 NS URLs created that are file URLs. And then in addition to just looking for file URLs, another very common operation is to only want to accept, say, image files or text files. You're not only interested that there's a URL, but you want to know about the contents of that URL. And so the second key is contents conforms to types. Is the key. The value you provide in the dictionary is an array of UTIs. In this case, we're looking for anything, any UTIs that NSImage supports. And in this case, when we do our read, out of those 5 items, only those that are file URLs that are also image files will be returned to us in NSURL. Now, I've done 2 reading examples, but this works equally as well with the can-read validation methods. And that sums up interacting with the pasteboard for reading. But again, now let's look at that NS Pasteboard reading protocol that you can implement in your own custom classes and play along. 3 methods: readable types for pasteboard, which is where you return the array of types that your applicator, that class is able to be created from. That list is usually shorter than those that you're willing to provide. And then init with pasteboard property list type. Again with the property list, not data, because you are able to specify how you want the data read off of the pasteboard. And you do that by implementing the reading options for type pasteboard method. And there are 4 reading options in Snow Leopard. The first is reading as data. This is the default if you don't implement the optional reading options method. And the NS data on the pasteboard gets handed into that init method as is. Then there's reading as string, where we will take the data and deserialize it to an NS string. And reading as property list, where we do the same with a property list. And so this is similar to the property list for type or string for type methods in the existing NS Pasteboard API. And there's one more reading option in Snow Leopard, because it's fairly common in custom model objects to implement NS coding, so you can archive those objects. And when folks do this, very often they'll take that and they'll also use that keyed archive of their object as the pasteboard type. And in this case, well, you already have written a perfectly good init method, init with coder. So if you specify reading as keyed archive, you don't even necessarily need to implement init with pasteboard property list type. You could just specify that what you're looking for is a keyed archive, and we'll call init with coder instead automatically. We'll just unarchive it from the pasteboard for you. Oh. I'll say it again. Okay, excellent. So that really sums up, that really does sum up all of the reading and writing API in Snow Leopard pertaining to this class level operation. So that was 4 methods for writing, reading, and validating, and then 3 and 3 for reading and writing so your own classes to play along. So not a lot of new API, but a heck of a lot of new functionality. But there is one, this is going to hose me with that. There is one piece that we did not talk about, which is I said we wanted to preserve being able to access things type by type, item by item. How do we do that? It's not represented in the API we saw already. To do this, we've introduced a new class in Snow Leopard called NS Pasteboard Item. And its interface is extraordinarily similar to the existing NS Pasteboard single item API. And it gives you very fine-grained control over exactly what types are provided or promised, exactly what types you're reading. And it really serves as this generic wrapper object that could represent any item, any things that could be on the pasteboard. So what does that API look like? If you're an NS Pasteboard aficionado like I am, I subscribe to Pasteboard Aficionado magazine. It looks exactly the same with one difference. We have set data provider for types instead of setting an owner for types. We're getting away from that owner technology, or that owner terminology, because data provider, I think, better specifies what's going on in this situation. Now, when would I use one of these, as opposed to the API we saw previously? Well, sometimes this mapping of a class to a list of types just isn't what you need in the application. Your app may perhaps be dealing with CG images, which are not Objective-C objects, but you still want to pull TIFF off the pasteboard and create a CG image, or pull PNG out of a CG image and put it onto the pasteboard, possibly multiple items worth. Pasteboard items are awesome for this sort of thing. Another case is you might be a delegate, or you might be subclassing a method where the object you're the delegate of or the superclass has already done a bunch of work in the pasteboard, and they hand you a pasteboard that's already filled out with stuff. Well, in that case, you very often want to iterate through each item in the pasteboard, look precisely at what types are there, and perhaps replace the data for particular types or provide or promise data for types of your own. NS Pasteboard item is extraordinarily handy in that case as well. Let's look at a couple of code samples. They're a little longer. We get the pasteboard. In this case, we're going to write some stuff to the pasteboard. We create an NS Pasteboard item, and then we fill it full of stuff. In this case, we'll set some TIFF data. We'll promise some PDF data. We could actually put as many as we want into an array. Once we have that array of pasteboard items, we do what we've done many times already in this session, clear the contents and write the objects. And everything we filled out in those pasteboard items, we get one item on the pasteboard that's an exact match. Now the other case where we might be reading stuff from the pasteboard, we get hold of a pasteboard, or maybe we get it from a delegate method that is called on us. We use a convenience method on NS Pasteboard that's new in Snow Leopard to get the pasteboard items. We iterate through them, and in this case, we're checking if the types on a particular item contain the TIFF pasteboard type, TIFF data, and if so, we're going to promise a PDF translation. Again, if you're familiar with NS Pasteboard's API, this is almost exactly the same. Now, just a couple notes about pasteboard items. They're designed to be temporary objects, so don't hang on to it, because once you write it to a pasteboard or you get one from a pasteboard, that item is now bound to that pasteboard. And in fact, it's also bound to that particular change count. So once somebody else clears the contents, you won't be reading anything out of that pasteboard item. So holding on to it won't do you much good. Just use it in that method and let them go. Excellent. And then finally, the final big change in Snow Leopard is this transition to uniform type identifiers. Now, one thing to note is that the new pasteboard APIs we've seen are UTI only. So the existing APIs of NS Pasteboard continue to work with pboard types, and they also work with UTIs, so they accept both. But the new ones, if you hand it a pboard type, will log and nothing will happen. It'll be pretty obvious something's gone awry. We've made moving to UTIs pretty straightforward. In most cases, it's a string-for-string replacement of constants. And another note is that we may be deprecating pboard types in a future release. So it's good to get a jump start on moving over. Now let's talk about moving over, this transition. So all of the commonly used pasteboard types have new constants in nspasteboard.h. So string, RTF, TIFF, and the like. And then for maybe less commonly used pasteboard types, we already have perfectly good constants defined in utcoretypes.h, the constant that defines that UTI type. And you would use those. And really, the only exception to this switching one string constant for another is the file name's pboard type. In this case, it makes more sense since we've always been kind of putting multiple file names into a single pasteboard item. It makes more sense to use the extra room to put one file per item. It also, since we're moving away from using string paths for files to using file references in URLs, it makes sense to write file URLs to the pasteboard and read them from the pasteboard. Finally, well, if you take a look at nspasteboard.h, details for each type are there. You just do a string for string mapping. Just a couple, custom types. For your own types, if you don't share your type with anyone else, you just need to declare a new string that follows the UTI naming convention, kind of reverse DNS naming scheme. And you don't need to formally declare the UTI in your info.plist file. However, if you have a pboard type, an existing pboard type that third parties, some other applications depend on, or perhaps even a previous version of your application depends on, then you will want to declare a new UTI and formally declare it in your info.plist, and then associate it with your old pboard type. Now, the AppKit 10.6 release notes have examples of this. So does the new pasteboard for 10.6 documentation. Two short types about the pasteboard. More types are now available. The example here is TIFF. Used to be the only bitmap type that the system would define. Now there are dozens of UTIs, so if you're only looking for TIFF and somebody puts PNG on the pasteboard, you're going to miss it. You should be asking for the broadest set of types that you can deal with. NSImage can help you with this, but again, the new API will take care of this eventually. And finally, say this with me 3 times fast. Peter put a pict upon the pasteboard, deprecated picks a poor pasteboard type to pick. I'm only going to say it once because, we're time limited today. But the idea of this is, please stop putting picked on the pasteboard. It's deprecated, was deprecated in Tiger along with QuickDraw, and it's completely unavailable. Well, it relies on QuickDraw, and it's completely unavailable in 64-bit. Now, Cocoa and Carbon do a lot to make sure that older apps that are reading and writing picked, usually 32-bit Carbon apps, are able to get translated picked, and that we're able to translate to a more modern type in your application. We've deprecated NS-picked pboard type that in Snow Leopard. Hopefully none of your apps actually will hit that deprecation because you've been off of it for a while. But if you find some reason why you absolutely have to put picked onto the pasteboard or look for picked, please file a bug because I think we have all the cases. We really want to know why you still need picked. And with that, I will turn it over. No? Call to action. Of course, we did all this. What should you do? First, move to UTIs. In most cases, again, string-to-string replacement. Move away from file names and the file names pboard type to using multiple file URLs. The other thing is now we can have multiple items on the pasteboard, so people are going to start putting multiple items on the pasteboard, which means that you should think about how your views and how your application should deal with multiple items. Now, in some cases, like maybe an NSImage view, which shows one image, still just finding the first image and putting it onto using it might be appropriate. But maybe in a drawing program, if there are 3 images on the pasteboard, you probably want to paste 3 discrete images into your drawing document. It's different for every app, so please give that some thought. And finally, just in general, adopt the new API. And with that, I will turn it over to my colleague, Peter Ammon, to talk about services.
Thank you, James. So, the services menu. We'll be doing an overview of what the services menu is about. I'll show you what's new about services in Snow Leopard. And then we'll do a sort of review of how you go about advertising a service so you get into the services menu, how you provide a service. So when the user chooses your services item, how do you actually provide that service? How do you consume a service so other service providers can use so that other service providers can use you can use services from other applications, is what I meant to say. And finally, how do you go about debugging services, which isn't something we've had a good story for in the past, but in Snow Leopard, there are some ways to debug them. And lastly, I'll show you really briefly a new feature in Snow Leopard about making a service from a workflow. So, an overview. Now, I'm guessing most of you know what I'm talking about, but in case you don't, the services menu is this menu right here, which is available in every application and has been there since macOS 10 first shipped. So, why do we have it? Well, if you have an application like image capture that can take images from a camera, you don't want to make the user have to go to your application every time they want to have an image. You want to allow them to put the images in Mail, for example, or TextEdit, or Pages, or any application that can accept an image. So image capture is a service provider. It provides services to, for example, Mail. When that happens, we say Mail is a service consumer. So even though this feature is provided by image capture, it appears in Mail, and the way this works is by passing data between Mail and image capture on a pasteboard. So the result is that any application can extend the functionality of many others. And this isn't my saying. This is, in fact, a line from the Next Step developer documentation 14 years ago. So something has changed since then. What's new in Snow Leopard? Well, there's no new methods and there's no new classes, but there are some changes in the way the services menu looks and how you go about declaring a service in your app's info plist. And I'll love to show you some of the changes. Oh, my computer went to sleep. OK, so here I am in TextEdit, and I'm in a plain text view, not rich text, and by default, the services menu is empty. And that's it, we're done. No. In Leopard, of course, there'd be a lot of services there, but they would all be disabled. And in Snow Leopard, we now hide services that would otherwise be disabled in Leopard. So, well, it's not entirely empty, right? There's one menu item. There's Services Preferences, which is available all the time. And this will allow users to enable or disable services that they want or don't want, and also to assign key equivalents or remove them. All right. So I'm going to switch to rich text, and I'll make this bigger. So now, again, there's nothing selected, but there's two items in the services menu. There's capture selection from screen, which is a grab service, and import image. And you'll notice that there's no menus. In Leopard, these would all be within submenus, but in Snow Leopard, the services menu is completely flat. You also, all right. Now, if I select some text, we have 6 or 7 items now, 8 items. And you'll see that there's categorizations on the left, so that you can have text and pictures, various categories. And of course, there's also icons that appear. But there's still some services missing. For example, Open URL or Reveal in Finder. So I'm going to select a URL down here. And we see that Open URL appears. So the services menu knows what URLs look like and can enable the services that handle URLs to only appear when a URL is selected. And it's not just web URLs. Here's an ancient Gopher URL, and it appears for that as well. So any URL type. Another example is email addresses. So the services send to will now knows what email addresses look like and will appear there. And file paths as well. So open, reveal, show info only appear when there's a file path selected. And we also can recognize text or scripts and languages. So the Chinese text converted services would appear all the time in Leopard. In Snow Leopard, they're still enabled by default, but they only show up if the text is written in Chinese. So here this is simplified Chinese, and I can select it, and it will convert it to traditional. And the last thing of note, all right. The last important fact is that services can also appear in the context menu. We show a subset of services, not all of them, but the ones that we think are most contextual, most relevant. So in this case, the convert selected traditional Chinese text will appear in the context menu down at the bottom. So, and all these features, all this contextuality is fully available to any application. And in fact, I'm writing an application, and I'll be using this application to demo how you go about integrating services programmatically. So this is an application which maybe shows some pictures. It's got each picture has a name and the date it was taken. To represent that, we have a single class photo. Photo has the image, the URL to the image, and the name and date that the image was taken, and it implements the NS Pasteboard writing protocol. So the photo will write itself to the pasteboard in a way that other applications can understand. So it would be nice if our application could provide services to other apps. For example, if you could just select a date in Mail and say, insert the photo taken on this date, and the photo would appear. So the first step to this is getting our menu items into the services menu. And we call that advertising. So how do you advertise a service? Well, you declare your services in the app's info plist. So here's an example of applications that provide a service. A tool called PBS will scan and cache the service declarations. A PBS existed in Leopard, but it was totally private. In Snow Leopard, there are some developer features for PBS that I'll be showing you later. And at runtime, AppKit will read the data cached by PBS and use that to construct the services menu. So here's an example of a service, one of TextEdit services, that is declared in the app's info plist. It starts, of course, with the NS services declaration in the root level of the info plist, and below that is an array, so an app can provide more than one service. It's an array of dictionaries. The most important key, or one of the most important keys, is the NS menu item dictionary, and that's just the title of the menu item. It has to be within a subdictionary with the key by default because of the historical way we used to do localization. So here the title is open selected file. Another important key is NS message, which is the name of the Objective-C method that your service provider implements. So this is what connects the programmatic service providing to the app's info plist. And lastly are NS send types and NS return types. And these are pasteboard types, or better yet, in Leopard and later, UTIs, which are the types that your service provides or receives. So open selected file will open a text file if you select the path, and in this case, it receives text. Right. Text. But there's another key in Snow Leopard, which is responsible for much of the contextuality. And this is the NS required context key. The service only appears if the required context is satisfied. So in TextEdit, the service should only appear if the text content contains a file path. And this is the key to deciding whether the third-party services appear in the services menu by default or not. You'll notice that the services menu was devoid of all third-party services, and we made a decision to disable them all by default, but give you this other way to get back in as a way of declaring, yes, I've updated my service for Snow Leopard. It has a nice longer title to work with not having the hierarchical menus. It's got a nice icon. I'm ready for Snow Leopard. And even putting this key in your info plist, even if it's totally empty, will enable your service to be available by default. Of course, if it's disabled by default because you wrote it for Leopard, the user can still enable it in preferences. So we saw that by default, services that have a required context generally won't appear. But if you want to receive a file path, you can use the NS required context key. Oops, I lost that. And we support not just file paths, but you can also ask for URLs, addresses, date, and email. And this is something Alyssa will be adding to later. We also saw that the Chinese text converter services appear only when Chinese text is converted. You can request a specific script. Here we're requesting simplified Chinese. For services that appear in the Finder, you can also request that my service should only appear when a specific file type is selected. For example, the folder action setup service would appear all the time in Leopard, even for text files or images. But in Snow Leopard, it appears only when a folder is selected, and the way this works is through requesting an NSSend file types of public.folder. Now, you'll still receive URLs on the pasteboard. We won't try to receive folders on the pasteboard, but all the URLs will, of course, point to items that have these UTIs. You can also request that your service only should appear in certain applications, in this case Xcode, or for a certain word limit. For example, a stock ticker application might only provide a service if exactly one word, a 4-character stock ticker symbol is selected. So let's look at how we declare our services in our info plist. Yes. So our services for our photo viewer application have an NS menu item named getPhotosWithName. This corresponds to the Objective-C method getNamedImages. It's going to accept plain text and return an image, public.tiff. And it's only going to appear if there's one word selected, because we'll say that an image can only be tagged by one-word tags. And likewise, for getPhotosTakenOnDate, this corresponds to the getDatedImages method, and it will only appear if a date is selected. So let's see if this works. There it is. So I'll select some text here, and indeed, getPhotosWithName appears. like we expect it to. Okay, well, great. You've gotten to the menu, and congratulations, the user selected your service. What happens next? So the text editor here is acting as the service consumer, and if your application isn't already running, it's going to go ahead and launch your application. And it's going to look at the send and receive types of the service that it's consuming. In this case, it's consuming text, so it's going to take the selected text, put it on a pasteboard, there it goes, and it's going to move the pasteboard all the way over to the service provider, which will read off the text. Service provider will look for images or perform whatever operation on the text that it wants to. And if there's a return type, in this case public.tiff, it will take that image, put it on the pasteboard, and send it back to the service consumer. So your app will be launched if necessary. You don't have to ensure that it's already running. And the way it receives the service request is by registering its service provider via the setServiceProvider method. And the provider receives a message depending on the service. This is that NSMessage key in the info P list that I showed you earlier. So let's look at how we provide a service in our photo viewer app. Get rid of that. So I moved it into a category, services provider. The first step is to register the services provider, saying NS application, I am the object that will receive the service request. And this you only have to do once. In this case, this happens at NS application did finish launching. So now we implement the methods that we said we would implement in our info P list, get named images. We'll start by pulling out any string that was selected, NS pasteboard type string, which is the UTI. And as a courtesy to the user, we'll trim off any white space. And if we were able to pull selected text out, we're going to find all the photos matching that text. So for every photo, if its name is equal to the name that we got on the pasteboard, then we'll add it to an array. And if we were able to find any photos, then we'll call clear contents and then write objects. So we write the photos, and because they implement the NS pasteboard writing protocol, this is all we have to do. And if we didn't find any photos, well, there's an NS error parameter here, and we can return a string saying no photo has that tag. Now, the get dated images, getting images that were taken on a specific date, is almost exactly the same, except that we want to pull a date out of the pasteboard. Now, even though we're looking for a date, we're getting an NS string on the pasteboard because that's the type we requested. But in Snow Leopard, there's a new API, the NS text checking API, which we can use to convert the string to a date. So we can use that to scan the string and pull out any dates. So even though we requested a date, we still receive a string, and it's our responsibility to find the dates within that string. So let's give these services a try. Here I am in Mail, and I'll say, check out this photo, and I'll pick a photo, and I can right-click, and I'll say get photos with name, and it works. Here's the photo. So. Okay, so now we've gone ahead and we've implemented a service. Oh, a few things to keep in mind. If your service doesn't have a return type, the process is asynchronous. So, for example, open URL, if you select that from TextEdit, it's just going to pass the URL to Safari or your default web browser and forget about it. But if it does have a return type, the calling app will actually sit and wait until your service gets back to it. Now, in Snow Leopard, users can actually cancel this process by hitting escape or command period. But still, it's a good idea to show some feedback, a progress indicator, or a dialog indicating that you're performing the service if your service might take some time to do. Okay, consuming a service. How do you use services from other applications in your app? Well, now with Snow Leopard, services are more useful than they've ever been. So users are going to start to expect them to work in places where they didn't previously work. Anytime I can select text or select an image or select a file, I'm going to want to be able to use the services corresponding to those types. Now, your views can implement an API to support these services, to consume services. And this isn't a new API. This is the same API we've had since 10.0. But if you can use a standard control, either NS Text View or Web View, these implement the API for you. So then, in that case, you're already done. But if you have a custom control, for example, our photo app has a custom control to display each photo, there's 3 steps you have to follow to implement the API. You have to register the types you support, indicate when you support those types, and then actually do the pasteboard writing and reading. So I'll show you how we implemented this API in my app. So I start by defining a convenience method, supported send type. So these are the types that we can send to apps that provide services. And we can send all image types, and we can also send file URL and this old deprecated, or I don't know if it's deprecated, but these older NS file names pboard type as well. So the first step is indicating the types we support, and we call that we call the register services menu send types return types method. And we pass the send types we support, and we don't support any return types, so we pass nil for that. And this only has to be done once. This is just a way of saying to AppKit, there's some sort of control in this application that can handle services with these send and return types. So now when the services menu is actually shown, it's going to go through and say, all right, is there a control right now that can handle the type for each of these services? And we'll pass us a send type and return type corresponding to the types for the services. Now, if the service doesn't have a send or return type, it's going to pass nil for that case. So because we don't support any return types, all we can do is send images and send file URLs. If the return type is not nil, the service expects to provide data back to us, and in that case, we'll just call through to super. But if the return type is nil, we may be able to handle this service. Now, if the send type is nil, the service doesn't want any input or output, so of course we can always handle it. But if the send type is not nil, we need to make sure it's one of the types we support. So we say supported send types. If it contains this send type, then we can support that. But we're still not done, because it may be that there's no file selected. Right? A service that operates on images should only work if there's an image actually selected. So if we have selected objects, at least one, well, then we can actually provide the service. We return self. Otherwise, we fall through to the super implementation, which is on NS responder. And the last step is when the user actually chooses a service that needs to interact with our control, it calls write selection to pasteboard. And this is a really easy method to implement for us. All we do is call clear contents and then write all of the selected objects, which are those photos, to the pasteboard. And if we had to receive data back again, we would implement read selection from pasteboard to do essentially the same thing, just to read the objects off the pasteboard. So let me show you how that's how this looks. So I can select an image, and in the services menu, we have send file. You can see it not only shows the services that apply to files, but also services that apply specifically to images, because it knows that the URLs we're giving it back are images, or point to images. And likewise, I can select, via the context menu, we'll see that the most specific services, here are the ones that apply specifically to image files, also appear. Set desktop picture. So that's all we have to do to consume a service. That wasn't very bad. The last step is debugging services. This is something I'm really glad we have, because in Leopard, you would often write a service, and it just wouldn't show in the menu, and you don't know why. Maybe your app isn't registered with the services architecture. You have to log out and log back in. Or maybe there's a typo in your info P list, and it's not going to tell you. It's just not going to show up. Or maybe there's another application with the same bundle identifier, an earlier version, and it's preferring that. So how do you go about figuring out why your service doesn't work? Well, the answer to that is the PBS tool, which I mentioned earlier. PBS is your window into the service's registration. And if you just run it with no arguments, it will look for any changes to any service anywhere on the system, and it will immediately update the services menu to show all the new services or remove any that have gone away. You don't even have to relaunch the apps. It will just do this for any app that's running. But it will also type check your info P list. So if there's a typo somewhere, if you have a dictionary instead of an array, for example, it will tell you that and tell you exactly what went wrong. And lastly, you can pass it the dump pboard option, and it will list all the services that are registered. So if you don't even know if it's found your app yet, you can call this, and it will tell you the apps that it's found. And an important note is that PBS is just for debugging. It may go away or change names later in the future, so you shouldn't write any applications that depend on it or write any installers that talk to PBS. You should only use it for debugging your app. Now, with this, we can figure out if the services architecture has found our application. But what happens at runtime if your service doesn't appear? We saw all these crazy ways to make a service contextual. How do we figure out why the service is showing up or not showing up? Well, the NSDebug services user default is your window into services at runtime. So for example, if I launch TextEdit with the NSDebug services, and then I pass it the bundle ID of the application that I want to find out about, the service provider, it will output incredibly detailed information about why the service is appearing or not appearing. So let me show you how I'd go about debugging services with this application. So I have a second application. I'll call it the next version, this buggy picture viewer, because it's buggy. The info plist here has services called get photos taken on date buggy and get photos with name buggy, so we can figure out whether we're looking at the new version or the old version. So if I open up TextEdit and I type some text and I go to the services menu, it doesn't appear. All I see is the non-buggy version. So how do I figure out why is my service not appearing? Well, the first question is, has it even found the service at all? So I'm going to call system. I'm going to call PBS with the dump pboard option, and it will tell me every application that it's found. So I'll search for buggy. It's saying not found. It hasn't registered my service. Okay, let's call PBS without any options and have it just register all the services it can find. So I do that, and it's telling me, uh-oh, there's a malformed services entry in the info plist for the service at this URL, and that's my buggy app. So what could be wrong? Well, it tells me that as well. The value for key NSWordLimit was supposed to be of type NSNumber, but it was a string. So let's see if that's true. Here's NSWordLimit. Oh, it is a string. This should be integer. I'll change that to integer, and I'll rebuild. And I'll run PBS again. Oh, it didn't report any errors. Let's see if it's actually registered our app. With dump pboard. There it is. Buggy picture viewer. Okay, let's actually try running the app. Let's try using it from TextEdit here. So I'll say Bridezilla, and so I show this, and it's still not showing the service. How do we figure out why not? I'll launch TextEdit again, but I'll specify NSDebug services, and I'll give it the bundle ID of our buggy service. And it's telling me, first off, that the buggy picture viewer service is enabled in the services menu and the context menu. So now I'll type some text again. And I'll show it. And it says that my service was disqualified because it has a word limit of 1, but there were 3 words. So that's pretty detailed. Let's get rid of 2 of these words. Oh, and there's the buggy service. So we were able to use PBS and the NSDebug services user default to figure out why our service wasn't appearing and debug it. We're really happy there's now a way to debug these services. And there's one more feature I'd love to show you, which is using an automated workflow as a service. And this is really cool. So all I've done is launch Automator, and there's a new starting point, service. Thank you. Okay, I've launched Automator. There's now a starting point called service, and I'll choose that. And let's say I'm just a huge Python junkie. I have to be able to run Python code from TextEdit and pages and everywhere I can input text. Well, I can make a service to do this with Automator really easily. So I'll start by making a run shell script command, and I'll just pass the selected text straight to Python, and I'll say that it replaces the selected text. And this should appear in any application. And I'll save it as run text as Python. OK. Well, I'll type some. This is a Python Easter egg for those of you who know Python. And in the services menu, well, it appears right away, run text as Python. And I select that. There it goes. And this is what happens when you run import this as Python. So it's really easy to make it only took a couple seconds just to make a workflow into a service. And if this is something which seems interesting to you, and I hope it does, well, we did this demo, I encourage you to go to the workflows as the using Automator and services to integrate with macOS 10 session, which is tomorrow. And also you'll learn about how to provide your application as Automator actions, so users can create their own services that involve your application. So what have we seen? Well, we've seen that NS Pasteboard has all sorts of new APIs in Snow Leopard. Common operations like reading and writing from the pasteboard usually require a lot less code. It's much simpler. And this is because we've shifted the focus away from keyboard types to classes. And where we still use types, we move them from types, the old keyboard types, to UTIs. We've also seen that services have been rejuvenated in Snow Leopard. And the bar for a service has been raised. So it's important that all macOS 10 apps that are relevant to services integrate with services as much as possible. Some ways to do that are to provide contextual services from your application, be a service provider, allowing services from other apps to be consumed within your app, and lastly, to expose your app as Automator actions so that users can construct services from your app. So for more information, you can contact our evangelist, Matt Drance, and the services implementation guide has been updated for Snow Leopard. If you search in Xcode documentation for the services implementation guide, you'll see all those keys that I showed you before, as well as the PBS debugging tricks. And the Pasteboard programming guide also is updated to show you some of the new Pasteboard APIs. I think with that, we have a song. Thank you.
Thank you, Peter. Actually, I just am really impressed with all the new services stuff. Just put it together. That's awesome. So for the last number of years, some session has a little guitar icon and a little song shows up at the end. And, well, this year, well, first let me introduce who else is on stage with me. You may notice that Gordy Friedman, who's the original Breakpoint guitarist, wasn't able to make it this year. But we have John Scallo, our newest Breakpoint, and he plays guitar well enough for the both of us joining us. And then, as always, on keyboard, the best slide advance man in the business, Mr. Victor Alexander. And so this year, as you've seen, we've made a lot of changes to Pasteboards, a lot of changes to services, and kind of talked through a lot of new Pasteboard APIs. So I thought this would be a good opportunity to do a little song that did some review of what we've just heard. And also, since the Pasteboard is all about getting from point A to point B, I thought what better style for a song than a little rockabilly traveling music. So without any further ado, gonna need a Pasteboard. Well, you got an application, has some things to share with them other applications. Well, you gotta stick that stuff somewhere. You're gonna need a Pasteboard, baby. Yeah, to move that stuff around. Oh, yeah. Oh, treat the Pasteboard right, and well, it will not let you down. Oh, no. Well, Pasteboard's quite inviting for the classes you invent. NS Pasteboard writing's the protocol you implement, so you can write them on the pasteboard, baby. Common Cocoa classes too. You just toss them on the pasteboard, and their data will shine through. Let's do some writing. First get a pasteboard, then clear them contents, and write them objects. It's literally 1, 2, 3 to write them on the pasteboard, baby. Easy as falling off a log. Oh yeah. But don't do the pasteboard wrong, no, or it might diss you in its blog. Oh yeah. Well, now you're dragging and you're dropping just the way you like to do. Oh, but that joyride will be stopping if you can't get the data through. You're gonna need a pasteboard, baby. The contents of the drag, oh yeah. So treat the pasteboard nice, yeah, and you won't hit a bump or snag. Oh no. I say NS Pasteboard reading has the power to create. It's what the pasteboard's needing, so it can instantiate what you're reading off the pasteboard, baby. All that its contents will allow. Oh yeah. Just ask for what you're needing, you'll receive without much sweat upon your brow. Let's read. First get a pasteboard, specify some classes, then read them objects, also literally 1, 2, 3 to read them off the pasteboard, baby. Yeah, you can read all night, but don't leave the pasteboard lonely, no, 2 reads don't make a right. And then sometimes you just might find that you require more specificity to determine type by type exactly what you read and write is supposed to be. So then you'd use a pasteboard item. You can read them, you can write them just as you desire. Use them to achieve your goal, or if you're just into control, that should surely set your soul on fire. Well, you might want to write a service to make any text a tweet. Then you might get nervous how that transfer will complete. Well, you're gonna need a pasteboard, baby, for the service you provide. Oh yeah. Well, just stick your data on there. Pasteboard takes it for a ride. Well, the pasteboard ain't too flashy, no, but that don't make me sweat. It's just shipping app without copy and paste, and see how far you get. You're gonna need that pasteboard, baby. It surely would be missed. Oh yeah. Oh, treat the pasteboard right now. I think your users will insist. Oh yeah. Oh, treat the pasteboard nice now. I think by now you get the gist. Oh yeah. I say use the pasteboard wisely and build an app we can't resist. Oh yeah.